Welcome to Lecture 3. In this lecture, I will discuss the tools and process involved in prototyping with the Arduino. There is nothing Arduino specific about either these tools or process. The Arduino is an incredibly effective creative tool because it accelerates prototyping dramatically. Prototyping is an iterative process whereby each iteration's objective is refinement of a prototype. It looks like this. It all begins with an idea, a problem, or a thing that you would like to build. Usually, you will have some prior knowledge of the problem area or some informed assumptions that can help you get started. But at the very beginning, you will not have the details or at least some of the knowledge necessary to help you in actually building whatever you're trying to build. So you go ahead and use what you know to build a prototype, version 1. This prototype may barely work at all, but it should be doing something that you can test and learn from. Testing yields information that you can use to adjust your original assumptions. These adjustments are called refinements. Iteration after iteration will yield more and more information and result in more and more refinements until at some point your prototype, be it version 1, 2, or 100, is the product or solution you aimed for. You could do prototyping using bare bones electronic components down to the transistor. However, with the Arduino, you can prototype much faster because 1, you will be using general purpose and already tested components which allow you to focus on your actual objective, and 2, you'll be using high-level tools to do so. Yet another really nice thing about prototyping with the Arduino is that you only need a few very basic tools. Not including the board itself, shields and other components mentioned in Lecture 2, you can build great projects with just these items: a multimeter, a solderless breadboard, jump wires, and a power supply. A multimeter is not strictly required for the majority of the projects you will be building as a beginner. However, having one and getting to know how to use it will help you a lot later on. Multimeters vary in capabilities and prices, but for $20 or $30, you can get a really nice digital one that will show you things such as voltage AC and DC, resistance, and continuity between two parts of a circuit. With these basic capabilities, you will be able to check that there is voltage differential between two pins or that a battery is charged. Check the resistance of a resistor and confirm that two parts of a circuit are electrically connected. A solderless board is a convenient way to connect components together without a need to use solder and a soldering iron. With a breadboard, you will just connect your components into electrically connected sockets. When you're done, you can clear the breadboard and use it for another project. In a breadboard, you get a couple of rows containing sockets that carry ground and positive voltages along one or both sides of the board, and multiple columns containing sockets that are electrically connected. If you could X-ray a breadboard, you would see something like this. You can see here how sockets are electrically connected vertically or horizontally. And here is a picture of a simple Arduino project where an LED that is connected to the Arduino pin 9, which is a digital out pin, and ground via a resistor. Instead of making the connections directly into the Arduino connectors, which will result in a messy bungle of wires, I plugged the LED resistor and jumper cables into a mini breadboard, a much cleaner setup. A jumper wire is a thin cable with pins at either end. Use them to make connections on a breadboard and on the Arduino headers. They come in many colors and lengths. One thing to remember, you don't want to run out of jumper cables during your prototyping, so make sure you have plenty available. My only rules when it comes to jumper cables are these. 1. Use red for positive voltages. 2. Use black for ground. Any other colors can be used to signify the connection of different kinds of components or functions that each one serves. For example, you could use light-colored wires for sensors and dark ones for buttons or displays. Up to you. The Arduino can provide power for itself and for the circuit you are building from the USB cable that is used to connect it to your computer. However, there are 3 obvious cases where you would need an external power supply. 1. If you want your sketch and gadget to continue its operation after your computer is turned off. 2. If your circuit becomes large enough so that the Arduino can't provide enough power. And 3. If your computer's USB port can't provide enough power. Here are 3 things you can do to deal with these situations. First, you can use an external power brick. This provides DC power from an electrical outlet. Anything rated at 9 volts to 12 volts and at least 250 milliamps will work with the Arduino. Just make sure it outputs DC power, not AC. I got mine from an old cordless phone. 2. A breadboard power supply. Very useful if you want to drive devices that need more power than what the Arduino can provide, such as a motor, directly onto a breadboard. I have one of these, which I bought on eBay for about $5. It provides my breadboard with both 5 volt and 3.3 volts selectable. And finally, a battery pack. If you want to go off the grid, then you need a battery power. You can buy plastic battery cases specifically designed for the Arduino on eBay, or just find an old broken battery-operated toy and recycle this battery pack. You just need this pack to provide voltage that falls within the Arduino's operating range. Okay, with all the logistics now out of the way, it's time to get into our first project. Let's move on to lecture number 4 and make an LED blink.